Hello everyone, welcome to this video. In this video, we'll be solving this question which states that the integers 5 and 15 are among a collection of 12 integers that form a group under multiplication modulo 56. We need to list all the 12 elements. Now this is a very interesting question because here if we assume let G be the given group, right? For this group, if we have only the elements 5 and 15 are given to us, so that means for this, and here what is the group operation? Group operation is your multiplication modulo 56, right? This is quite a large number here. So for this we are only given the elements 5, 15 with us, and there are in total 12 with such integers. So that means we would have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 more elements which are to be found for this complete group. How we can do that? We shall make use of, we shall use this closure property. Why? Because the given group G is given to be closed, right? That G is given to be a group which has this closure property. So for closure property, we have two elements. We can just combine them through this group operation and see what element do we have. So whatever is that element, that would surely be present in your group G. So when you compute 5 into 15, that comes out to be 75, and when you compute 75 mod 56, you would have 19 as the remainder, correct? So that means this element 19 should obviously also be present here, right? If you have 19 here, it should also be present here, right? Then once you have 19 with you, what else you can do? You can again compute 5. Why I am just multiplying it with 5? Because our calculation would be simpler because 5 is smaller than 15. So 5 into 19, when you compute, it comes out to be 95, and when you computed mod 56, you would have 39 as the answer. So mod by mod 56. So you can clearly see this 39 is also a group element here, right? Next, what you can do, you can compute 5 modulo 56 with 39. So once you are doing this with 39, you have the multiplication as 195, which would be equivalent to 27 mod 56. 27 would be the remainder here. So you see, if we have 27 here, correct? So here also we are having this 27. Next, what we can do, we can compute 5 multiplication modulo 56 with 27. So let's see, what do we have? We would have 135 here, and when you compute it under mod 56, you would have 23 as the radius, correct? Remainder. So this 23 is also a member of group, right, which is not known to us. In a similar manner, you can compute each and every calculation. So next, what we can do, we can compute it with 23. So 5 multiplication modulo with 23, it would come out to be 115, and when you take its mod 56, it would give 3 as the remainder. So you see from here, this 3 would also be present in this group, right? Next, we can calculate 3 with 5, right? So 3 with 5, that is 15, and 15 is already present in our group, so we can skip that one. What about 3 into 15? That is not present in our group. 3 into 15 is 45, and which is equivalent to 45 only, 45 mod 56. So you see, this 45 is also present within our group. Now 3 is the smallest number. Let's take it to solve all the other calculations, right? Because we are exhausted with our numbers, and it would make our calculation more easier. So once you calculate it with 15, you have calculated it with 5, it is 15. 3 with 15. Next, what you can do, you can calculate it with 19. 3 into 19. Let's see, what do we have here? You can take any number. I'm just taking the one which is more suitable to me for calculations. So 3 into 19 is 57, and it is equivalent to 1 when you compute it under mod 56, because 1 is the remainder here. So obviously this is the identity element of the group 1. So you can substitute it here. So here you have 1. So this 1 is also present here, correct? And when you take its multiplication with any number, it would be just 1. So we are done with this 19. Next we can calculate it with 23 or any other number, correct? 39, you can calculate it with 39 also. So let's do it. So so let's compute it. 3 multiplication modulo of 56 with 23. So it would be 69, and when you compute it under mod 56, that would give you 13. So that from here you obtain 13 as another member which is present within your group. So you have 13 here, correct? Because it was already not present within your group. Next, what you can do, you can compute the calculation with 13. So 3 multiplication modulo 56 with 13, it is equals to 39, which is already present in your group, right? 39 is already present, so we'll not write it. We have a repeated member here. Next we can calculate 3 with 39. That is not what we have already calculated. 3 with 39, it is equals to 117, and when you compute it under mod 56, so it is equals to 5. Now this is also present within G, so no need to write it here. 5 is already present. Next, what we can do, we can compute 3 with 27, right? That we have not computed here. So 3 with 27, that is equals to what? So let me tell you here. It comes out to be equal to 81, and when you compute it under mod 56, you see we have a new number here which is 25. So you can write 25 within your set. This 25, you can write it like here. This is already not present here, so we are left with only one member here. So let's compute other member and see what can we have with us. So let's compute it by some other member. So we can compute it with 45. So when you multiply 3 with 45, you have 135 here, which is equivalent to 23 mod 56, correct? So what is 23 mod 56? So you can very clearly see it is already present within your group, right? 23 is already present here. So we will not take this element, so that means we would have to repeat our calculation. So this is not what we are seeking. So what else we can calculate? We can calculate it with 25, that we have not done. So let's calculate it with 25. So it is equal to 75, right, which is equivalent to 19 under mod 56, and this 19 is already present within our group, so we will not take this one. So that means we will have to take some other calculation. So what about 3 with 3? That should also be present within our group. That is 9, and which is equivalent to 9 mod 56, because 9 is smaller than 56. And surprisingly here 9 is not present with us. Hence we can write 9 here, which is the last member of our group. So this 9 is a member of our group. So we have obtained all the elements here for our group, and this is what we wanted here. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.